Hello, everybody out there in YouTube land. Good times for all, or Zachary Zabala here if you prefer. Today, I'm having my first guest on my stream ever. We have LCKing, also known to some others that are a little bit closer to him as Lucas from Australia. He's got a brilliant mind. We're kind of on different sides. I don't know. He's more chemistry, battery based. I'm more electric field, magnetism based. So us putting our heads together, I think, is going to be a cool thing to see here. I'm going to start it off just with a quick thing about electricity and what electricity is and how important it is in our world, how much it actually affects and controls this place that we live. But right before that, I just want to say hi to Lucas. How we doing?
How you going? Yeah, good, mate. Thanks.
Awesome. Yeah, I've been excited all day. I usually take a nap after I do some yard work. I was out there clearing out some more leaves and all that kind of good stuff, and I haven't been able to.
That's good.
Yeah. Alrighty, so I am going to share this real quick and just show this little, just a quick little video from Cammie and I's How the World Works. And it's Walter Lewin explaining how important electricity is.
Understanding electricity and how crucial it is to continue to
Can you hear that,
investigate the
Lucas?
subject further.
Yeah, I can hear it.
And magnetism is all around us. We have electric lights, electric clocks, we have microphones, calculators, televisions, VCRs, radio, computers. Light itself is an electromagnetic phenomenon, as radio waves are. The colors of the rainbow in the blue sky are there because of electricity, and I will teach you about that in this course. Cars, planes, trains can only run because of electricity. Horses need electricity because muscle contractions require electricity. Your nerve system is driven by electricity. Atoms, molecules, all chemical reactions exist because of electricity. You could not see without electricity. Your heart would not beat without electricity. And you could not even think without electricity, though I realize that even with electricity, some of you may have a problem with that.
As you heard.
All right.
Well, that about sums it up. That's the show.
Yeah, there you go, folks. Electricity just controls everything. But yeah, that's one of my favorite videos by Walter Lewin. Just explaining. That's the very beginning of his course, actually, for his when he was teaching at MIT, his 802 electricity and magnetism course. He taught, that was his first explanation of what electricity is. And I don't think it could be said much better. It pretty much controls everything.
Oh yeah, definitely. Yeah, even the cells in your body. I mean, it's everywhere. Definitely.
Yeah, I mean, you couldn't see, you couldn't, like you said, you wouldn't be able to think. Your brain just, all the stuff wouldn't fire and get together, and your heart wouldn't beat. And well, a lot of this just doesn't apply to all of that. I mean, he didn't even touch on the electricity of all the natural world around us, the electric fields and things like that. This is just a taste of what electricity really controls, what he just said. But yeah, I mean, to put it simpler, everything. Electricity is everywhere, it's in everything, and it's causing reactions at all times.
Yeah, and that's what's really fascinated me about the galvanic cell or the battery idea, is because it's the process that actually creates it. So creates that electricity. So, researching that has been, a lot of fun. Just to, sort of get a handle on what the process is to actually, create it. So, and as you said, when I've done this research, it applies to everything. It's, you can't look at covers the whole spectrum.
Yeah, it's kind of hard to get away from it in the end. You can focus on certain things and this and that, but in the end, you can't ever exclude electricity from what is taking place.
Yeah, so I'll be doing certain searches for different things, trying to find out something about, say, electrolysis, or something about our world, and then all of a sudden I'm getting pages and pages of stuff about the body. So it's super interesting, and that it all ties all these different sort of classes of different segments of science together. It's really the underpinning thing to me.
Absolutely. So the basics of electricity, I would say we were talking about this just a little bit ago. You have your positive and your negative. And, you can call one black and one white. And then there's a big gray area in between where all kinds of things take place.
Yeah. It really does just revolve around this idea of polarity. There's a third thing, which is your neutral. So it's three things, but in general, you're looking at the positive and negative, and so that polarity idea really can be applied to everything as well. So
Absolutely. Well, yeah, the neutral kind of lays in that gray area in the middle.
yeah, exactly. It's that central point between the positive and negative. It's when those two join up, in a sense, there's a neutral ground.
So what brought you to this? All started from yesterday. We were doing the ironworks over there on TFR, and you just threw this out in chat like, hey, we need to talk about this a little bit more. Do you remember what it was that really grabbed you, or just made you throw that out?
Well, it was this idea of gravity, and this sort of ongoing discussion about what's actually happening. Gravity, using the word gravity, but what's actually
we use it
happening.
loosely.
Yeah, exactly. So it was, and you were talking about it, and you will have a definite understanding of this idea of levitating things with electricity, by use of induction or whatever it is. But it was really that, getting into the heart of this concept of what's actually happening in our world to create that downward motion, or
that acceleration we see.
Yeah.
Absolutely. Okay. And this has been a very passionate subject of mine for years now. I've been playing with electricity. I think I got my Van de Graaff in 2018, maybe 2000. No, it was before that, 2017. And what I did, I just followed through Walter Lewin's MIT physics course on electricity, his first, until he started getting into, resistors and transistors and capacitors and stuff like that. I really wasn't, I am interested in that stuff, but my main focus was in how it works in nature naturally around us, and the different things that we can tell just by the measurements that we get here in this realm that we live. That's what really drew me to electricity, was the idea of confirming whether or not we, what this place we live on really is, specifically a shape.
Oh, yeah.
Now, they've done a great job hiding it, and we'll get into that here in a little bit. So, but that's why I really started getting into electricity.
Basically for me, it was dealing with that galvanic cell and how it actually is created, and what are the elements that's needed. And in a lot of ways, it's the electricity is created from an interaction with matter, so that you can't sort of separate the two either, because it's electrochemical. So the elements that create the electricity are, they're, can't be separated. Mumbling a bit, sorry.
No worries. No, I understand exactly what you're saying.
Yeah.
Yeah, they're a part of the elements. Without the electricity, which we still, even physics, mainstream physics says we don't fully understand these nuclear forces, they call them, these subatomic forces that they can't even get down small enough to see, but they theorize about them. And they still, I mean, at least Walter Lewin, he'll openly admit that we don't fully comprehend these things yet. We have ideas and models, but we don't know it yet.
No, it's really difficult to understand, and I just put it elementally. I just see, say, Earth material as or elements as either positive or negative. So they got that polarity, and they want to join to each other depending on their charge. So they're always trying to find that equilibrium, and then they build a structure based on that, those interactions. But
Yeah.
generally, it's like, tiny little magnets rearranging themselves into different structures, and that's where you get that sort of incoherency as well, depending on the structure. It's basically going to be Earth elements are nearly always going to be neutral in charge, and it really takes energy to actually break apart those, to actually.
Oh yeah, to try to align the poles of the particles takes a huge amount of power.
Yeah, and this also, when dealing with this, you can't sort of separate the idea of the different phases of matter as well. So you'll have solid, liquid, gas, and then plasma. So they all tie into what these elements are doing. Are they able to become, as you go up that sort of scale, in a sense, they seem to be able to be easier to be polarized, and that's where you get that separation of charge. I'll see. Am I able to screen share? Or are you going to show a video or something?
Yeah, you can. Real quick, I just wanted to show a real quick one. It's just Walter Lewin, the man who we just saw speak. I'm sorry, folks, he's my go-to guy when it comes to electricity. I love Ken Wheeler when it comes to magnetism. I just have certain people that I like to, at least, I mean, I've learned electricity from other people, but I like the way Walter Lewin explains it to, he explains it so a child can almost understand it. That's what I love about him. He's a great teacher. But yeah, just real quick, I want to show this one.
Yeah, too easy.
Audio. All right.
Part 2.
So what holds our world together? Well, on the nuclear scale, 10 to the minus 12 centimeters, very important are the nuclear forces.
Okay, 10, I just got to stop it real quick. 10 to the negative 12 centimeters. So he's talking very, very tiny, minute. He's talking about atoms. The smallest things that, supposedly that we have. This is what he's talking about when he's saying this. So on very small scale, is it the nuclear forces?
On an atomic scale, up to thousands of kilometers.
Okay, sorry. Again, remember that, up to thousands of kilometers. So holding our world together for thousands of kilometers, a very large area.
It's really electric forces that hold our world together. But on a much larger scale, planets and stars and the galaxy.
Okay, so gravity only comes into effect when we were talking about like the sun and the earth, or the earth and the moon, and things like that. It does not talk about the apple falling from the tree and hitting Newton on the head. Those were in the last category, you know, the atomic forces, for thousands of kilometers. The Earth is all the way up to the ionosphere, you know. The Earth is being held together by electric forces. And not until, he said that, not until we start talking about these larger things.
It is gravity that holds our world together. Now you may say, that's very inconsistent with what you just told us, because didn't you tell us that D cancels if you compare gravity with electricity?
Yes, but keep in mind that most objects in the universe have only a very small amount of charge per unit mass.
Okay. Now, how would they know any of this stuff? See, they're making assumptions about the sizes, the electric charges, all these kinds of things about the lights in the sky, just so they can put their model together. But that's pretty much the end of this one. I just wanted to show that even at MIT, you know, where supposedly some of the greatest minds go and come up with some of the greatest inventions, they are not taught that gravity is holding the apple that fell down and hit Newton in the head. It is taught that these are electric forces holding our world together.
Yeah, and they're just working with a model that doesn't sort of bring it together and bring understanding to them. So that's basically it. They're out of context.
Mm-hmm. Yeah, I mean, and the saddest part is there are physics professors at universities that don't teach it this way. He even said, according to the math, this is how, well, he didn't say it right there. Later on in the video of his lecture, that is 802 lecture 1, that was right around 40 minutes in. His very first lecture, you can type it in on YouTube, 802 electricity and magnetism. It'll be first video that pops up. But yeah, he talks about it. I just try to keep my YouTube video short so people's attention span can hold on to it.
Yeah.
Seems like an ever-growing problem. The longer the video, it seems like the less people watch of it anymore.
Yeah, that's right.
But yeah, electricity is it's what is holding all this together. He even said it right there, electricity, and then he, you know, we can go on later and we'll show you what he's talking about. But according to the globe model, we are between two dielectric planes. We have the Earth and we have the ionosphere. One is positively charged, one is neutral, and then there's the negative below it, or wherever that negative charge is going to. But that is their model. It's not just this gravity thing. And they have to have the ionosphere, which, by the way, is impossible according to physics. It cannot be recreated. But it has to be in order for their model to work. But the fact that they even said they have an ionosphere is because they have to. They have to do this. Because this is what we measure here in this place.
Oh, yeah. So you're saying that the ionosphere, well, the ionosphere created from the sun's, you know,
Yeah, photons.
charge.
Yeah, all that nonsense.
Yeah.
Yeah, they say it isn't an electric charge. It's not like we're in an electrostatic field, which we would need to be in one to be able to send, you know, to pick up a positive from it. It's just, it's kind of infuriating that I didn't get this, and I had to be shown this. But it's only been brought up 3 times in the last 120 years by people in papers. You know, 3 times I could find 3 different papers written on this subject. How, hey, wait a minute, how do we have an ionosphere? How is this thing actually working?
Yeah, and then they tell us, you know, they can bounce things off it. I mean,
yeah, exactly.
It's like, yeah.
So yeah, but electricity, we were talking about shapes as well, and how shapes. I'm just going to go through a couple videos here real quick. I'll explain them before I go through them, and then I'd love to try to, you know, answer any questions you might have, or maybe somebody in chat, and then we can start looking into the galvanic cell a little bit. But
Sure.
The next video I wanted to show you guys is can the laws of electricity tell us the shape of the Earth? Um, where am I at here? I, I, I guess we'll just play this one. Um, I wanted to try to not play too many of them like that, but this is one of those I really didn't get to watch through too well. So let's see, screen share, audio. Oop, there we go. Sorry, folks. I'm still getting used to all this stuff.
It is well documented that there is an electric potential gradient in the atmosphere that rises at a rate of 100 volts per meter in elevation from the Earth's surface. Now, knowing that alone doesn't answer our question. Instead, we will go straight to the man himself, former MIT physics professor of 4 decades, Dr. Walter Lewin.
So let's start the Van de Graaff. You can't see it, but I turn it on. It's rotating now. I have to put charge on here, so I'll touch it with the Van de Graaff. And so this is now charged. It has the same charge as the plane. The plane is being charged. And here you see the angle.
Okay, folks. And you see, can you see my mouse in here? Oh, sorry, guys.
Yeah,
The angle. Okay, well, the angle he's talking about is from right here, from straight down right here to this. And he's talking about on this large plane right here, that this angle will fall off as he moves away slower than it would on a sphere. Electricity on a sphere works just like light does as a point source. It falls off at the inverse square law. So if we were just on a sphere that had a negative charge without the ionosphere, we would see in our gradient that we had here, the 100, 200 volts, 300 volts, it would really be 100 volts, 200 volts, 400 volts, 800 volts, and it would increase at the inverse square rate. And it doesn't. We know that it goes up nice and gradually at the same, it's nice and even as it's rising. This also tells us that we are not on a plane like this. This plane right here, eventually, as you got far enough away, actually, I guess we haven't been high enough to test it yet, I should say. They say if you were on a plane, it would be stronger, but then you would start seeing changes and it would get to the inverse square law eventually. There'd be an algorithm depending on the size and the charge, but eventually you'd get so far away, say he was 2 blocks away, this big plane that he's standing next to would look just like a point source in space. So he's pretty much showing how shapes can determine, it will show us the way electricity would act on it. Now, the way that our electricity acts on Earth, it is in this, oh crap. Okay, I'm just going to quit screen sharing. Okay, so the electricity on Earth is almost as if we are in between 2 capacitor plates. The way that it's acting, the way that it's getting weaker at that certain increments per meter, it's not as if we are just on a flat plane by itself or a sphere or a square or anything like that. It's acting as if we're between 2 capacitor plates.
Yep, exactly. That makes perfect sense to me.
Okay. I'm sorry, Lucas. What was that?
Yeah, it makes perfect sense to me.
Yeah, and this is all testable, repeatable, in a lab. You can try all this stuff, and it doesn't matter what kind of equipment you're really using. You can apply an electric charge to something, and it's going to act accordingly. I got a lot of that from, did you happen to catch Witzett's debate about gravity?
Only a little bit of it. Yeah,
and he was using some of my videos as demonstrations, and they were saying, well, where do you see a Van de Graaff generator in nature? And it's not the Van de Graaff generator that is the experiment. It's the electric field in nature and we're, we can measure it and see that it acts in a certain way. It's positive at the top, negative at the bottom. All I did was reverse that and put the positive on the bottom and the negative on the top.
Yeah.
We have to use instruments to do our experiments.
I was reading about, like, they were testing this a long time ago, and the charges, they're actually out on ships and doing tests of it. So, and this was before there was things to interfere with it, such as the signals that get flown around nowadays, and they're out at sea testing these charges. So it's I forget exactly what date it was. It was in the 1900s, I think. So they've been doing this a long time, looking at these charge differentials and atmospheric charges.
Oh yeah, this isn't new by any means.
No.
And I think they've advanced dramatically more than they've let on. I think they can do some pretty amazing things with electricity, magnetism, vortex technology, gyroscopic technology. There's all these kinds of things that they can do that we have no clue about at all.
Yeah, look, I'd even think that they'd, some of their little crafts and things like that, all they'd have to do is set up charges on the outside of them to actually start to get them to move. So I'll see if I can screen share. I'll go through this little diagram that I drew up.
Do I have to give you permission or anything? I've never done this before. I'm not sure. Let me while you're doing this, I'm gonna say some hellos. Hello, Cammy. Yep. Hey, Bogan, Ryan, Q Vincent. Hello, friend. Clary, what's up, brother? Dawn, how are you doing, darling? Great to see you here. Thanks for joining us. Bolt Gun, welcome. NJ Jeep Girl, what's up, darling? So nice of you joining us. Of course, Bob from Globebusters. Iconic Mitch, what's up, brother? How you doing? How do I? Oh, there it is. Okay, now you're sharing.
If you want to present this whole screen, you can.
Sweet.
View that square.
Doesn't seem to be showing up on the YouTube though.
It should here in a second. I think we have a slight delay on. Let me check and see how the YouTube's looking.
Okay. Yeah, there it is.
I did it up here.
Okay, yeah, it's there. Cool. Yeah, go ahead, Lucas. Show's yours.
Yeah, so basically I drew this little diagram. It's not the greatest, but hopefully it gives you some idea about what I was talking about before with along this. You can see my mouse or not? Yeah, you can. So you've got the solids down the bottom, liquids, gas, plasma. So there's just in my view, it's just an increase of energy. And so when you have solids, that's where you get that incoherency happening, and that's basically they're at a neutral charge, and you can see here that you have the negative and the positive joining together just like little magnets, and they'll create a neutral, and it depends on the structure which way all these little elements are facing. So then when you start to move up and then you go into liquids, then you have water, and basically these become freer moving, and that's where you get that electrolysis. I mean, the electrolyte can start happening, so that's a movement of energy through a liquid medium. And yeah, then you get the gases, and again there's more energy, more free flowing, and then till you get to a plasma, and that's where really things start to take on a different and in my mind that's where most of these things separate to a higher degree, and you can get this sort of monopole type thing happening. But in general,
that makes so much sense.
Yeah, the the neutral ground is neutral because of that, these two elements joining together in all their different fashions, and they're all linked. It becomes neutral. So that's, while you say that the ground is negative, in some sense it may be on a surface level, but not within it, in a sense. Does that make sense?
Yeah, you're not, how do you say it? You're not getting negatively charged from standing on the ground.
No, that's
It's
why you can draw.
neutral. Yeah.
Yeah, it is neutral, and that's why you drive your neutral ground for your electricity into the ground itself. If you were just to lay it on the ground, it wouldn't work so well. And then you see up here, I got on the left hand side, there's a little square box. When these, different charges join together and create a neutral, there is no energetic interaction. If they're stable, well, they're not going to be affected by the outside energetics, basically. And so because of that, they're just going to fall down to their neutral ground. And you see what I'm saying? There's no interaction. Yeah. So, and that's basically why I think objects fall. So you're left with buoyancy and density, but in general, these earth elements are neutral. So they're not.
Well, there's. Let me say one thing. Even though they're neutral, they are within an electric field. So induction will take place, and they'll polarize. And then density and gravity, or density and buoyancy, will take place.
Yeah. Okay.
That's how I see it, at least. I think anything within an electric field, anything that you put inside of an electric field, which we are always in at all time, induction is going to take place. There's the negative charges in your body are going to go towards the positive above you, and the positive charges in your body are going to be at your feet, trying to connect to the ground. And that constant, that electricity above us is pushing.
But it's going to be so minute for
very minute. Yeah, that's why I said.
For something that's, as I'm saying, it's neutral, and it might as well be, but you will have what's called paramagnetism, or that slight, offset, depending on what it is. But in general, once it gets to, it really can't overcome that, the density of the object itself, in a sense.
No, not at all.
Unless, and this is where we can get into something later, where you increase the electric charge so much that it overcomes the density of the object and starts interacting with starts polarizing the solid earth elements themselves.
I have one.
You can stop.
Yeah, I just have one to. I have a video to show you.
Yeah.
Here we go. And this one, I'll talk through it while it's playing. So we have some balloons there, right? Floating, helium-filled balloons that are supporting this Karen B pin that's attached to a wire. Now the wire is going up to the positive on my Van de Graaff generator, and the negative is on the other side, away from it all. So all I'm going to do is apply a positive charge to this pin. So there is a buoyant force pulling up right now. But as I start turning the crank and giving this more electric potential, it now wants to go down towards the ground. Just with the electricity alone right there. Just by changing the electric potential of it, now there's too much electricity. See, it was nice and neutral. Now it's not neutral anymore. So we're getting that positive charge to it, and now it wants to go down to the ground. big shout out to David Weiss for putting that one together. Thanks, brother.
Yeah, so that's sort of showing that the surface of the ground is negative. Is that right?
Yeah.
Yeah.
Well, it's
But
not so much the surface is negative. It's showing that
oh yeah,
by
there's a
increasing
gradient.
the electrical potential, the gradient, it's going to start working its way through the gradient to try to dissipate all that electricity off it, to get away from the positive electricity above it. It's 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 going to be pushing it down.
Yep.
So
Sweet.
that when you, with the Earth being neutral, it's almost as if it's always a pushing. But then you do have dielectric or incoherent, magnetics, which is always an attracting force. That's why this is kind of like optics. There is no one thing that is controlling all this stuff. It's not like, oh, I see that over there because of this. Well, it's because of Rayleigh's criterion, and it's because of atmospheric. It's, all these different distortions can take place. And it's to try and put it all into this one little line it is impossible. You can't explain it all away. Like the electric field part that I kind of go towards and saying, yes, there's a force here. Well, you step inside a Faraday cage, where's the electric field? You've kind of dismantled that electric field around you. There's so much more still to learn. So much more still to learn. So much more testing to do.
Where did I hear that? Were you talking about it where there was a guy that done an experiment where he basically did a Faraday cage and people got sick because they weren't able to get that being the charge?
No, I haven't heard that. I will definitely have to look into that.
Yeah, I don't know where I heard it the other day. It was just like these guys. This guy was experimenting and basically, they all started to get sick because they weren't in the charge. So that's interesting as well. I have to research where that came from, but could be rubbish. But sounds right.
It's interesting, worth taking a look into for sure.
Yeah, definitely.
And then, well, I'm going to show another one here. During Witsit's chat, they were talking about, magnetism not having an effect on gas. And in its normal state, at its normal temperature and this and that. And I don't know. Maybe it does have to be at a certain this or that. It's almost impossible to test that stuff. How do you test a gas with a magnet without it, seeing a reaction or an interaction in some way, however minute it is? It almost seems impossible to look at oxygen interacting with a magnet.
Yeah, exactly. And that's the thing, where we can only really work on different earth elements. So a magnet's only really going to interact with other sort of earth elements rather than the gases, which are,
Now, an interesting thing, though. Oh, sorry. Go ahead.
Yeah, okay. Yep.
Oh, I was just going to say, one of the interesting things is that electric fields definitely affect gases. Have you ever heard of St. Elmo's fire?
Yep.
That is electrical discharges that are coming from the ground that are so strong that they create like a burning bush, or it looks like a blue Christmas tree almost. I'm sure they come in different colors depending on what gases are present and how strong it is and all that kind of good stuff. But it creates a thing called a coronal wind. And what it's really showing is that the static electric field, the electric field has the forces that, are applied to everything else when you put them in this, I believe are still applied to gases themselves. So this is a little video. This is an old one. I was going to redo this one, but it's pretty much just, I have my Van de Graaff generator here. And here is the that looks like the negative, actually. I don't know why I'm using the smaller negative one, but I have a nail attached to it, a metal nail just taped onto it, and it's right next to a candle flame. Now when I start cranking this up, this candle flame is going to start blowing. I don't have enough power to blow it out, but and this just doesn't work with just metal either. Let's see. Come on, flicker. Do something. Oh, yeah, I was supposed to be way up here. There we go. So the candle flame is just sitting there, and then I start cranking on my Van de Graaff generator, and you can see it looks like there's something blowing on it almost, doesn't it?
Yeah, it does.
And I know people could say, oh, you're blowing on it, this and that. It's kind of a real soft, steady blow from that thing. It doesn't get very strong. Cryosan. Have you ever heard of those guys? They're out of
No.
Russia. They play with electricity, crazy stuff. They charged up a guy with 1,000,000 volts of static electricity.
Oh yeah, and I
Yeah,
I
he's
have
just
seen a
pointing
little
his
video of that.
fingers from like 2 feet away at these candles, and they're all getting blown on from 2 feet away. And this is going through a human body.
Wow.
So
That's
even
amazing.
when you're pointing your finger, all that electricity in your body that's coming off of you is now focused into that one point.
It's like qigong.
Yeah. Yeah. So imagine if you could actually learn to harness that and really get it stronger. I don't know. Maybe people could do this at one time. Maybe a lot of these cartoons and stuff aren't so as far fetched as people, think.
Maybe,
I don't know.
yeah, maybe just exaggerated. Yeah.
Yeah. Yeah. I always wanted to be like the guy in Big Trouble Little China, the little Wong, where he shows the lawyer magic. He's like, wow. He's like, that's nothing. But he has the electricity going back and forth between his fingers. I would
Oh,
love to be able to do something like that.
I'll see if I can screen share again,
Yeah.
and I brought this guy up plenty of times, but I just find him fascinating. I don't know. Let me just. Oh, have you still got one of mine open or not? Oh, hold on.
Oh, sorry.
Yeah,
I am
hold on.
supposed to
No,
click
it's all
on
right.
it. I wasn't even paying attention. If you go ahead and try
There you
again.
go.
Yeah, I had
Yep.
it. There we go. Sorry about that.
No, it's all right.
Oh, I think I have seen this before.
Yeah, this guy. And it's funny because he was trying to test things. He was working under the globe model. I always bring him up because I just find what he did was fascinating, and it's a little bit. People do the same sort of experiments, and I'm sure Walter Lewin has done similar stuff. And basically, he was using that high static electricity and getting things to levitate. And then he was studying what these little balls. He would use little silver balls and things like that in there.
Wow, he had to be playing with some really powerful electricity.
Yeah, he actually built his own static generator, and he would dry the air out really completely before it went in. So he had sort of his own patents on what he was doing, and then he would use some sort of like a vacuum sort of scope thing to suss it out. So there's some of his plans there.
Wow.
Yeah, so he's got a little vacuum tube of the spectrum. So he was actually studying what the auras that these suspended metallic balls were doing, and he'd heat them up, and they'd operate differently or move in the field differently. They'd oscillate. He would try different sort of materials as well, which could again do that levitation.
Wow.
But this is in, I think it's in 1900s again. But
Should have been
yeah.
built on, And yeah, I think a lot
exactly.
of this stuff is the stuff that they've hidden from us completely.
Yeah, but
If
his
they would've showed me
experiments
that
were
in science, I would have been all about it back in the day when I was younger.
mm. Yeah, so it was just in one of these science and invention articles, but that's what sort of tipped me off on, you know, how the model that I present, how it could work just by that electric, the high electric field, being able to levitate things, and you know, whether this is, I don't know if I've got the picture here, but
Yeah, and you got to realize the charge in the atmosphere. I know it doesn't sound a lot, 100 volts per meter, but lightning strikes 180 times a second, I think, somewhere right around there across Earth. And that's a lot of electricity.
oh, tons, there's
3
huge amount.
million volts per cubic meter. 3 million volts just in 1 cubic meter in order for that discharge to take place.
So whether this is right or wrong, it's just something I found interesting, and this is the image that they give us for the solar winds, and you can see here the sort of layout of it. And if you go back to what this guy was doing, you'll actually see that the same solar, or
Wow.
that same
Yeah, pattern.
yeah, the same patterns operation there. So, you know, that was another thing that sort of just struck me. I was like, oh, that's really, really interesting. That would show the solar winds exactly how this guy is showing these balls under static electricity working the same way. So, and he was studying the auras off these balls that was happening.
Wow.
So I just thought that was interesting.
Yeah, and actually, I've done this in a different way, but with my little Van de Graaff generator, I'm able to make stuff float around.
Yeah, like you were saying, that those things build up charge surrounding them, and then they want to dissipate. So, yeah.
Oh, this is the wrong video. Let me skip forward. Okay, yeah, here's the one right here. You may have seen this video. It's the Van de Graaff generator. Let me go back a second. So we have our Van de Graaff generator here. The positive now, again, on Earth, the top would be positively charged and the bottom would be negatively charged. And the electric field would flow, in this direction, laterally, nice and straight, 90 degrees perpendicular to the planes.
Mm-hmm.
And what I did instead, I put the negative up here and the positive down here. So that's all I did was reverse the polarity of the electric field.
Yep.
And the crazy thing is now this is just a piece of tissue paper, nothing, enormous or anything, but that's not a lot of power. And as long as there's that charge in there, that tissue paper will just stay there. There's a force pushing it up. Now, I also tried this with wood. And here you can see the little wood filings flying up to the top. And they just sit there. Now, you got to take into consideration the size of the plate. That's what this all was back here. So the Earth is 131,208,000 feet across. If you were to take the South Pole to the South Pole, just the measurements they give us on that. I know that's not exact or anything like that, but this is the size of the cookie sheet or the pizza tray right here, which we break down to a foot. Now, Mount Everest, I think, 29,035 feet, top of Mount Everest. That would be 0.003 inches. So the tallest peak on this plane would be less than the width of a human hair off of that plate. So these things are taller than Mount Everest. These little
Mhm.
pieces of stuff right here, of wood. If you scale it. Then I tried it with metal filings, iron filings. No way this will work, right? Too heavy, too dense. I started applying a little bit of electric charge to it. Iron filings start flying around. Some of them even do parabolic arcs reverse. They go like this. They'll come down and then go right back up.
Yeah, right. And this is exactly showing what that Mr. Pickett was doing as well, just in a different way.
Yeah, yeah, exactly. Just different. And then again with human hair this time, you know. So I mean, it's all materials are affected by electricity. I haven't found anything yet that isn't affected. Some people might try to say, well, water isn't really all that affected by electricity. You know, it runs through it and this and that, but it's not going to affect like the shape of the surface, right? Not a static charge. But now this wasn't even really meant to be. I didn't mean to do this or anything. I was just playing around, seeing what was going to happen. And I got a lot of flack for this too.
Oh, did you?
But you can see here, let me get it to where it's flat. I think I started this video off with it curved. Yeah, okay. So all I have is that's metallic paint on there on a ping pong ball, a tray of water, and my Van de Graaff underneath. So there's going to be electric interaction between the ball and this, and then the water is just going to follow the electric field. It's going to lay 90 degrees perpendicular to the electric field. So if this right here wasn't curved, then this right here wouldn't have been curved like that. If that was a perfectly straight plane, now you'll see when I'm done here, you can tell I'm moving it around. But when I stop charging it up, it starts to go back to normal. And then, look at that. Think.
Yeah.
And that's pretty still water. It's not running, it's not moving, but it's bent because it's lying 90 degrees perpendicular to the electric field. That's how all this stuff works. Everything follows this. I think it reminds me of the Ferguson map right there. Not saying this is true at all, just saying it reminded me, that shape that I saw right there kind of reminded me of what we see there.
Hey, yeah, that's interesting. Real interesting. Well, that's why I said with the galvanic cell, the sun being the cathode, the moon being the anode, so they're acting as a polarity, just exactly the same as a battery, and the different charges will attract different substances depending on their charge. So once they get up into the atmosphere, they're going to want to adhere to either one of those. And even with the galvanic cell, the negative side, so the anode, is creating oxygen, and the positive side is creating hydrogen. So just on those two elements themselves, they have a different polarity. So oxygen is negatively charged, and then hydrogen positive. So just from that alone, that creation of those two elements, and if they are adhering to the positive and negative, will create an attraction or a repulsion.
Exactly.
And so, yeah, when you look like that, it's pretty simple. And there is also anodic dissolution, which is basically an adherence to the anode, or that the surface of the anode, the oxygen adhering to the surface of the anode. So that in itself will create a negative charge.
Exactly.
And then you have basically the salts of the ocean and those gases that are created from the sun are heating up the oceans and lifting up things. And then you have the negative and positive attraction of certain elements, and then you get into the electrochemical side of things, which is the chemical interactions of the salts, and a type of atmospheric electrolyte being created, which does refine things on its own. But so yeah, it sort of goes into all that sort of stuff, and how that actually those energies are created then.
Yeah, I need some chemistry re-education. I was not paying attention at all to that class about just the chemical reactions, their names, their functions, what's actually taking place. That's
Well,
why.
it really just comes down to your salts act as an electrolyte, so that's where your electricity is able to flow through a medium. And then it's really the sulfurs. The sulfurs are the critical bit because they seem to interact with the anode or cathode, and they create that um, that change in element, I guess, or that yeah, it's really the sulfurs that start to eat in and create that movement. As far as I can tell, it's still complicated, but
Yeah, I have some. Like I said, I just have. It was kind of like with electricity. It's just learning what a lot of these words mean, and not so much just learning what they mean, but knowing what they mean, like off the top of your head. Just you know, you have it down. You comprehend what's going on there.
yeah, well, the sulfurs are similar to like basically a creation of acids. So if you look at it that way, the acids are able to sort of eat into something and break apart things, and that's where you sort of get that dividing up of the elements, I guess.
Absolutely. Yeah, I have a lot more to learn about the stuff you're covering. Um,
Oh,
yeah,
so do
it's
I.
just it's
Don't
it's
worry.
scary. It's like standing there looking in front of an ocean. I know I say this all the time, but a lot of these things, the mud flood, Mandela, and all this stuff, it's kind of like another flat Earth. And I'm
Yeah.
not done learning about all this stuff yet. I don't mind watching them and all that stuff, but when you get into really deep, hardcore research, I learned this with the sun and the moon. It's so hard to research two different things, vigorously at the same time.
Hmm. Yeah. Look, there is a lot to learn about this subject, definitely, and yeah, we're not done. That's for sure. There's I yeah, I feel like I'm just as Crow says, still wearing diapers. So yeah, just still trying to work it out, applying things, and there's definitely stuff I've probably missed, but yeah, hopefully we're getting a little closer. That's all.
Yeah, that's all we can do. I mean, to know it all, I don't think is really a goal anybody should be shooting for, Um, knowing how everything works, I mean, that would take 3 of Noah's lifetimes.
Mm.
You know, there's so much to learn, but pick something and don't become a master of it, but don't be scared to dig in and really get into it either.
But the other thing is, in saying that, there is there's a fundamental blueprint that seems to be, in my mind, when studying the galvanic cell, there's a fundamental blueprint of how energy operates and how it moves. And if we understand that to the best of our ability, then we should be able to apply it to everywhere. And that, it's like these laws or scientific laws or whatever. I mean, they're laws and they apply to everything. So, and that's the same with electricity. It's, maybe not so well understood, but once we do understand, you know, how it operates, it should nearly be a law. And then once you understand that law, apply it to everything, and it should, you know, give you a decent amount of feedback, a decent amount of knowledge back, you know.
Yeah, and that's the thing. A lot of people think of electricity as somehow not being able to be studied scientifically because it lies out of the realm of our human senses. You know, only on certain phenomena do you see electricity in its natural raw form. But it doesn't mean that it isn't around us everywhere at all times, even in us. You know, just because which are amazing, our senses are fabulous. I love them, but they are very limited to the scope of what we have, you know, obtained with other measuring instruments. Um, Look at just like X-rays alone and all these different things that, you know, infrared, all this stuff that we can't see without technology. But it is, you know, it's sound. It's testable, repeatable, and it works. It's like putting something in an electric field. You can scientifically test what is going to happen to those objects in an electric field. Now, what is causing this electric field? I don't know. You know, I don't. I bet it's very similar to what you're working on, though, and the ideas that you have. That's why one of the reasons I'm so intrigued about what you're doing, because all of this is natural. I don't think there's a guy up on a crank running in a treadmill, you know, spinning a wheel, charging the plate above our head. I don't think that's how it works.
No, it seems to me just a natural cycle of how elements work together, and the natural elements are just moving around, and you know, there's and the states that these elements are in will, you know, affect how they're going to operate. But the other thing is to think about is, you know, electricity isn't just your lightning and things like that. It operates subtly as well, just like you're saying, you know, through the oceans, as long as you've got an electrolyte, and same with in the body. Um, it's basically, you know, it doesn't have to be this big bang and a charge and all that sort of stuff. It can operate smoothly and subtly
Yeah,
as
very
well. So
subtly to where you have no idea it's even there.
yeah, like the currents on in the oceans, you know. And the other thing that the thermogalvanic cell shows us is that is whenever you have a heat differential, you're going to have an electricity type of flow as well. So, you know, and we have heat differentials all the time, even just
Everywhere.
subtly.
Yeah.
Yeah, and that's, you know, what moves the winds and things like that. So,
Yeah, it's
um,
that pressure mediation, everything trying to become neutral,
yeah,
equal
exactly.
out.
And it's that operation of everything trying to become neutral, and then certain activities, and I think mainly the sun, the activity of the sun creates energy input to really release things and start to polarize things again. Do you know what I mean? So it's
Hmm.
you have to increase the energy to create that extra vibration, extra energetic movement within things to release it. Then you get that polarization happening again. So it's the sun sort of feeding on itself, you know, or, you know, becoming a closed loop system. That's It's really amazing, and that's what differentiates it from, you know, in my mind, the world, to a battery and to a thermogalvanic cell. While they're good examples, our world seems to be, you know, a closed loop system. It feeds on itself. It's whereas the battery, you're drawing energy out of it to apply to an appliance, or even electrolysis, you're putting energy into something. Whereas our system seems to be working on itself constantly, so it's super efficient.
Yeah. Yeah, it's a beautiful, I mean, it's almost perfect, isn't it?
It's
It
perfect.
really is. Yeah.
Yeah.
All right. Well, I have our first guest who has jumped in.
Sweet.
And we have Bob from Globebusters.
Hey guys, what's
How you
happening?
doing, man?
Hi. How you going, Bob?
Doing good, doing good. Just listening to the conversation and very cool. So I'm kind of interested, Lucas. I think the one part I missed. I think I was walking into Zach's room downstairs trying to help him out, but you were just getting ready to say something about what you thought the so-called gravity was, or the downward accelerative force, or could I get your take on that again? Because that's been kind of a really hot topic with us lately, and I'm just trying to get what everybody thinks about that.
Yep. I'll pull that picture up again so it's easier to see, because it's just easier to have a diagram with me. If I can find it. There it is. Right.
Wow, Josh Corey of the Iron Realm has a really neat question. Has anyone measured electric potential during different moon phases?
I'm sure somebody in mainstream science has, but I don't know any flat earthers that have. And not only that, it's electric potential of what? I mean, low level things. Is somebody like? There's several ways I guess you can do that with the kite. I don't know. There'd be a lot of different ways to do that, but it would be interesting to see what that does, and also changes in the magnetic field.
Yeah.
Now they do
Well,
have that stuff online though, but I don't know how much I trust the online stuff.
Well, I
I
know
did
the electric.
send you something a fair while ago, Bob. It was about these guys doing sort of an underground antenna, and they were basically able to pick up things from miles away when the moon was around. So there's there's definitely an interaction, and plus you can even talk about how the moon interacts with plants and you know that sort of thing, and they did that on Iron Realm Media as well, talking about having water that's been affected by magnets and things like that to increase productivity. So there's a whole mythology that surrounds the moon and planting and how it affects plants. And so my idea would be it's driving the salts and interacting with the waters as well. But
Yeah.
anyway, I'll show you. Yeah.
I was just going to say I was actually very very much aware of the growing things under the influence of different magnetic fields. In fact, Ken Wheeler talks about that a lot, and I was blown away. That never even occurred to me to think of something like that. But apparently, certain plants, certain foliage respond extremely favorably under different conditions to specific polarities of magnetic fields. Which who would have thunk it?
Yeah, it's amazing.
Did you see those pictures last night that Dom shared with us, Bob? The difference in the tomato plant sizes and everything?
Oh, yeah, I did see that. That's crazy.
I mean, that is... Have you ever seen anything like that, Lucas?
No.
Yeah, isn't that just ridiculous? The dramatic size change just from magnetizing the water?
Yep. The other thing is,
there's somebody who tried to join with the handle Chunky. It says your devices are not connected, friend. You're going to have to connect the mic at least before I can add you to the stream, it says. So I apologize about that, but I'm not going to be able to add you in until you get your stuff figured out on the other side.
So getting back to this gravity thing, basically what I was saying is that the solid ground, or these are basically neutral. So this is where you get that or these two polarities, they link together to create a structure in whatever form, and then as you go up, then you're going to get high increases in charge, which we've sort of showed, and anything that is basically linked or joined up is becoming more neutral. And so the effect of the charge surrounding it is, well, it's not really going to affect it. it has some effect, but very little. And then so all you're left with really, because there's hardly any charge interaction, things are just left to their own devices, as in how dense they are, buoyancy, and that sort of thing. So they just basically want to fall to that neutral ground because they're not interacting with the charges around them. If you had a monopole or something highly charged, then they would do the things that we were showing before, where Zach had the two plates, and they'll want to lift up. So, and that's why I think with some of these gases and things like that, they're actually more polarized. Say something like hydrogen or those lighter gases, not just because of their density as well, but also because of their polarity and charge.
That's
But
true.
That's my idea of it. Yeah.
Yeah, because I mean, one thing that I've tried to figure out for quite a while is, to me, it's still an anomaly, the whole helium predicament, because I've proposed this thought experiment. I don't know if you heard this. I've talked about this a few times. If you've heard it, just stop me. But you know how you can have two balloons, and if they're not inflated, you can hold one in each hand and then just drop them, and they'll both hit the ground at the same time. And then if you take those same two balloons, you fill them up with air, so they're exactly the same volume, and drop them, and they'll hit the ground at the same time. But then if you do one with air and one with helium, and then let them go, of course, the one with air goes down, the one with helium goes up, which, on the outside, you think, well, why would that matter? The buoyant forces, it's almost like if the helium was acting as an anti-gravity type of thing. And the reason I find that anomalous is because the buoyancy really has more to do. I mean, the only thing that's contacting the surface air, of course, is the latex outside of the balloon. But if you take helium gas itself and put it into a steel container, the weight actually increases. So there's an actual increase in weight. And to me, that's always been really anomalous. And so the only thing that I can think of that might cause those effects with helium and hydrogen both is they're both diamagnetic. And I think that may have something to do with it. But
well, if you put it into the steel container, well, you would be sort of creating a Faraday cage as well, but also it depends how much you put in there. Like you would have to
thought about that. Yeah,
you would have to
over about before becoming liquid. Before that.
Yeah. Even if it's a gas, it's almost in a Faraday cage then. So maybe that has something to do with it. But yeah, I'd say it's more positively charged. That's what I get out of some of these.
Yeah, that's actually a good thought, because the balloon, of course, is just latex, and but if it's in a metal container, then you could be shielding it off from some of those EM effects. Yeah, that's a good possibility. I never thought about that before.
Yeah, something like that. Yeah.
Because the mainstream explanation, for helium is simply that it's just more buoyant. But it's like, but it's not. It doesn't have anything to do. It's not coming in contact with the air. It is inside the latex balloon, which is in contact with the air and is displacing that air. And we know that the helium itself has weight. So it's like that never made any sense to me. It's like there's got to be something else at play here.
So they're saying it here that it's got zero charge, but
well, it is they do list it as diamagnetic, though. Helium and hydrogen are both listed as diamagnetic.
Yeah, okay. So there you go.
Yeah.
Maybe it's charged in some way. Yeah.
Yep. And of course, like I said, when you really think it through, the mainstream explanation, it doesn't make any sense, because again, that buoyancy, the gas may be lighter, but what you're acting against in the buoyant force itself, that rubber or that latex shell, that's what's coming in contact with the air, right? So that just never made any sense to me, and nobody has ever been able to offer an explanation that makes any sense until now. And the container itself offering that, EM shielding, may be a good explanation for it.
Yeah.
That's good.
You would think the the balloon itself would have some shielding too, but maybe not as much.
Well, maybe from electrostatic, because obviously latex would be,
Yeah.
an insulator, but not electromagnetic. That's not going to phase it. So
Yeah.
yeah. Yep. Okay, cool. Well, that may have given us a clue. But isn't it
Cool.
amazing that nobody else has ever really questioned that, and people are willing to just accept that? Oh, it's more buoyant. It's like, yeah, the gas is maybe, but it's still inside of the balloon, which is what is causing the displacement. So you can't. It just doesn't make any sense, the mainstream explanation. So
Yeah. Cool.
yeah. So anyway. Yeah, I mean, there's obviously, some anomalous questions about gravity, but I think the biggest thing is if you just go back to the original definition of gravity and list it as weight, and of course weight is a force, but they don't even want to lend anything with the word force in it to gravity, and frankly, it's always been my position, whatever it is, right? If there is an acceleration, then the only thing that can cause an acceleration is a force, and that's an axiomatic law of physics. So, it puzzles me, when people come out and say, well, it's not a force, but you can think of it as a force. Obviously, they are conjuring that from the Einsteinian model of gravity, right? Because it's bendy spacetime. And so I don't know exactly what phenomenon they call bendy spacetime, other than supposedly the mass itself is bending that spacetime. And of course, it's all bullshit anyway. But
Yeah.
but I would tend to think that out of the two, the Newtonian would be closer, and still it would have to fall into that definition of whatever is causing an acceleration would have to be a force. So. I don't know. It sure has really been a hot topic in the flat Earth community, though, and I'm glad. I really wanted that to happen, but it's amazing how many people have really got their egos staked on this.
Oh yeah.
Well, Bogan has a question from chat. Does the pressure of the helium matter? The pressure of the helium.
Well, I know at some point it goes back to a liquid state, right? But the gas itself still has weight, and that's the thing that's puzzling, right? It's like if the balloon itself weighs a couple grams and you add a few fractions of a gram in weight, but the outside volume is identical to that of the air balloon, then still, why the hell does the helium balloon go up and the air balloon go down, right? See, that's the puzzle. So.
And the same thing can be said for hydrogen. I mean, that would be positively charged or charged as well and want to go up. So yeah, they have the same properties, and I'd say they're more like monopoles, and they'll just want to be seeking their equilibrium, and that just tends to be in a higher up, basically.
Yeah,
they want to go up to where they're going to find equilibrium.
Right, because obviously, if you put a helium balloon in a vacuum chamber, it doesn't go anywhere. So there's still something there that appears to be interacting with an external atmosphere, right?
Yeah.
So
yeah,
I don't know, just so many freaking anomalies. But yeah. Oops.
Cool.
Just drop the link in chat one more time to see if anybody else would like to jump in before we ask people's final thoughts or whatever, and about wrap it up for today, maybe.
Yeah, cool.
Yeah, it sounds good.
Yeah, this is your very first kind of hosted stream, isn't it, Zach?
Yeah, and this, man, you were right. StreamYard is amazing. It is so simple and easy.
Yeah, it's easy peasy. I really like it. The only thing that I wish was a little bit better on it is if you could have like queued shared screens. In other words, sometimes if you want to go back and forth between a tab that is shared with sound, because sharing the whole screen with sound seldom works.
Yeah.
And I don't exactly understand why, but that's kind of problematic. But other than that, I mean, it's really, really good. And I think also maybe their audio equalization for music could be a little bit better also, but it's not bad. It's not too bad.
Yeah, I was trying to figure out a way to just put in some music at the beginning without a video or anything like that, and I wasn't seeing it, and time was getting short. I was like, that'll be for, I'm thinking about maybe doing this every weekend, every Saturday maybe.
That'd be cool. I know how to do that. That's the same way we do our intro. You can actually preload a file that actually uploads to StreamYard, and then you can just play it.
Okay. Well, yeah, I was just thinking just the audio though, without.
Well, yeah, it doesn't have to have video.
Just audio.
Yeah.
Okay.
Well, I mean, you could put just a blank background, but it is an AV type of thing, so audio and video.
Okay.
But you don't have to have any video running. You could have a solid background or something like that. And hey, Chris Van Maitre's out there. How you doing, Chris?
Yeah, much love, Chris.
Awesome.
We should be having a chat here soon.
Yep. I still think we need to get Chris to move to North Carolina, get him out of Texas.
Yeah, he's got it pretty sweet with his job right now, though. It's going to be hard.
Yeah, I know he does. It would be hard to walk away from that. He's kind of, king of the forest in that job from what I understand. So that's cool.
Well, it doesn't look like anybody else would like to be jumping in. So, gentlemen, thank you so much for coming and joining me. This was awesome. I had a lot of fun. Lucas, you're always welcome back. If you're free next weekend, you want to continue. Bob, you're always welcome too, man. Anytime. But yeah, I'd like to have this conversation more often, just talking about electricity and the forces involved and gravity and the stuff Lucas is talking about, because trying to figure out how it happens naturally, I think is one of the coolest puzzles of this place.
Yeah.
Not having the guy in the wheel turning the thing at the top. Figure out how it all like
the big hamster in the sky, you mean?
Yeah. We got to watch it. People will start saying, "Oh, flat earthers believe I'm a hamster," Yeah.
Yeah.
But thank you, gentlemen, so much for joining me. Lucas, you got anything coming up here? Planned?
No, not really. Well, if it comes to me, I'll do another video or something. But yeah, not much.
Well, I know at some point, Lucas is going to be joining us on Globebusters.
Excellent.
We'll be kind of doing a demonstration, or we'll be talking about his work on there. But I still have to get together with him for that. So that's one thing he will be doing here in the near future.
Yep. Sweet. Oh well, thanks, Zach. It's been an absolute pleasure. And,
yeah, absolutely.
Great talking to you, Bob.
All right, good talking to you too, Lucas, and thanks, Zach, for having us on.
Yep, my pleasure, Bob. Do you know any clue what the show might be on tomorrow? A little sneak preview for people here.
Well, we were going to go through Austin's debate with Brian's logic, and that has turned into such a freaking can of worms with Battle of the Egos.
Yeah.
Austin's just like, he's like, you know what? I'm sorry I even did it. And you got him crawling up trying to get on Jaron's show and claiming misrepresentation and it's so unfair and all this stuff. And then I was going to go over it, and Austin's just like, you know what? Let's just leave it alone. And I'm like, okay, well then we got to come up with something else. So we're actually on Skype right now running some ideas back and forth. But me, I never come up for the show ideas until either late Saturday night or Sunday morning anyways. But it'll be something.
Well, I can't wait. I'll see y'all there in chat tomorrow. Again, thank you all for joining us. This was a lot of fun. I think we will, Boggin. I'm going to start doing this at least once a week. I'll try to keep it around the same time period, just to get like a rhythm going and a flow or whatnot. But yeah, I think this is one of those topics that's very important and needs to be, openly discussed on panels where, we can have nice, calm, rational discussions about things.
Yep, for sure. Ego free.
Yeah. Well, all right, that'll be it. I am going to end it once again with my favorite teacher ever, Mr. Walter Lewin. I've never met the man, but he's probably taught me more than any teacher that I've ever had. just watching his YouTube videos. Honestly, you can get a whole physics degree without the piece of paper from MIT. You know, it's $27,000 a semester back then, and he offers it for free here on YouTube. So the choice is yours if you want to know all this stuff or not. And if you're having trouble, come join us on the weekends, and maybe we can answer some of your questions and help you out.
Mm-hmm.
This is Good Times for All here, signing out. As always, thank you all for watching.
Investigate the subject further.
Electricity and magnetism is all around us. We have electric lights, electric clocks, we have microphones, calculators, televisions, VCRs, radio, computers. Light itself is an electromagnetic phenomenon, as radio waves are. The colors of the rainbow in the blue sky are there because of electricity, and I will teach you about that in this course. Cars, planes, trains can only run because of electricity. Horses need electricity because muscle contractions require electricity. Your nerve system is driven by electricity. Atoms, molecules, all chemical reactions exist because of electricity. You could not see without electricity. Your heart would not beat without electricity. And you could not even think without electricity, though I realize that even with electricity, some of you may have a problem with that.
As you heard.
And that's it, folks. Remember, take care of your neighbor, take care of your friends, take care of your plants, take care of each other. It's a really big world, and it can be really small at the same time too. It's all about how you look at it. Much love to each and every one of you out there. Y'all have a great week, and we'll see you around. Take care.